No, no. I don't know if 1 or 2 is a smart board and if 1 or 2 is my computer. Now, who's got a craft? Israel, do you have a craft? Hand me a craft. All right. So when we graph this thing, I think it looks like something like that. Does that, here you go, Israel. Does that look good? Okay, cool. So now that I'm looking at the derivative, now that I'm looking at f prime of x, can you tell me where this function is increasing? Where is the derivative positive? I think from -1 up to 0. Any other times? And I'm not going to include either one of those. Now, are you confident that that's really -1? Oh, it's not -1. Okay. Again, we're allowed to use our calculator. And it's not -1. We actually find that it is -0.8 what? 857-ish to 0. Okay, good. So don't go by what things look like. You actually have to search for or calculate the zeros. So we're talking about things making a changeover right here. Okay, where are we decreasing? -∞ to -0.857-ish. The other place. And from 0 to infinity. And 0 is not in the domain. We got to make sure we don't include that in any of these intervals. Okay. Do we have a maximum anywhere? And how would we know? We're going to have a maximum where? And does that happen? None. Do we have a minimum? The minimum occurs at x equals what? -0.857. Now, that's fine for right now, depending on how the question is asked. If I said at what x value does the minimum occur, we've answered that. If I said, what is the minimum value, what would you have to do with this -0.857? Put it back into our original function, which we found right back here. Okay. And what if I had said at what point is the maximum? You'd have to have the x and the y. All right. All right, so we have found increase, decrease, max, min. Now, what about finding concave up, concave down points of inflection? Yes, we want to know something about the second derivative, but what we're going to do is we are going to focus all of our attention on this first derivative. The first derivative can give us all 7 of these values or intervals that we're looking for. So if we are looking for where we are concave up, concave down point of inflection, we're looking at the second derivative, which is the slope, f double primed of x, is equal to the slope of the derivative. So if I want to find out concave up, concave up is where the second derivative is greater than 0. And so what I'm going to look at when I look back at this graph, because I don't want to have to graph a whole, you know, the derivative and the second derivative. I'm coming back here. Where is the slope of the derivative? Where is the second derivative positive? Would probably start down here, wouldn't it? Now, would I have to go back to this graph that's on my calculator, and would I have to do a second calc, the minimum? Find this minimum value, because that is where the slope of the derivative changes from being negative to being positive. So what is that x value? Negative 1.28, you said? 6. Okay. Do we got a lot of people coming up with that? So it looks like our slope is positive from there all the way until 0. All right, so I'm going to say we are concave up from negative 1.286 to 0. Are there any other places where the slope of the derivative or the second derivative appeared to be positive? Looks like from 0 to infinity too, doesn't it? All right. Now what about concave down? Yeah, we're looking for the second derivative being less than 0, or the slope of the derivative being less than 0, and that appears to occur right here-ish, doesn't it? So I think we would say from negative infinity to negative 1.286. I'm sorry, I do believe I'm on the wrong slide here, aren't I? All right. I want point of inflection. And I really kind of mean to be on this slide and writing this stuff on this slide here. Looking at the graph of the derivative, find where its slopes are positive. That means the original function concave up. Negative, where the original function is concave down. And where concavity changes. Those are points of inflection. Well, if I look at what I've written here, where does concavity change? Yeah, at x equals negative 1.286. And if I needed to know what that point was, I'd go back to my original function. Where else does concavity change, or is that it? I'm suspicious about 0, but at 0, at one side of 0, I'm concave up, and at the other side of 0, I'm also concave up. So concavity did not change at 0, is there? Now, how can I just look at the graph, and Pranav mentioned this earlier, how can I just look at this graph and tell where there is a point of inflection? Yeah, if there is a max or a min f primed of x this is a point of inflection for f double prime, or for f of x, because that indicates that the concavity is changing. So again, we can find everything looking at the derivative. And wherever the derivative changes, wherever there's a max or a min, the concavity is going to change on f of x. Okay. Now, that's not a reason for anything. If you are going to say why there is a point of inflection at negative 1.286, what is your reason for saying that? Point of inflection, f double primed of x does what? Changes from what to what? And we have got to be very specific with those signs. We can't just say second derivative changes sign. All right. Now, is that everything we were supposed to do here? Yeah, I just kind of wrote it on the wrong slide. Sorry about that. Okay. We will stop there.